Um, Hello. So today our group. Yeah, let's start. Okay. Uh, so hello. So today our group team 3 are going to present about the artificial neural network in electrical power company. So my name is Tuan Muhammad Zuhimi, then I am assisted with my friend Muhammad Hakimi, Muhammad Aiman. Go next slide. Now I pass it to Muhammad to present.
Thank you. My name is Mohammed Muhyiddin, and at first I'd like to start the first part of our case study. Here we have the implementation of an artificial neural network in electric power company that we've chosen. So in any electric power company, they need to keep track of how they use the power, how the power is consumed, for each of their customers, whether they're in the industry or private properties, whatever the customer is coming from, it need to be tracked so that they can manage the power supply. They can control the power supply in order to give each customer how much they demand. This is very important. And secondly, they need to identify the time in which the consumption or the usage of this power is the least. So they can also determine how to schedule the maintenance, which sector to focus on and which sector to avoid. So knowing where it's used least and where it's used most will help reschedule the maintenance for the suitable time, so that it will not have any impact, or at least any great impact, on how the customer uses the electricity during their peak hours. And now I'll pass on to my friend.
My name is Muhammad Hakimi. So I will tell about the benefits of implementing artificial neural network. There are many benefits. One of them is to prevent overload, to reduce energy poverty, to increase consumer awareness, energy efficiency. Artificial neural network also helps to provide end user with safe and stable electricity, improving the load forecast accuracy, supply electricity at the least possible cost with a constant service quality. And last, it helps in saving in operation and maintenance costs. Next.
Okay, thank you, Hakimi. Next, I will present to you about the suitable data, the training data that we use for our artificial neural network. First, the data that we use is electrical power consumption based on time. The electric power company can predict which time least power is used to do some quick maintenance in case something happen like a damaged part and such. And secondly, in addition, company can manage a power supply for the time to avoid the wastage. As you can see, the graph at the left side, uh, it shows the data for the consumption per day, 24 hours in kilowatt per hour. The profile that we choose is like the Saturday, Sunday, and the working day. Every day, the consumption of electricity that we use is different. Okay, next I will pass to my friend.
Okay. So with this data in our hand, so we post it for it to use the network architecture with this like this. So why first is the input layer, we divide it into 7, which represent the part time of the day. So if we see at the clock, it's like a circle here, we can divide it into 4. So if we look at in a 24-hour system, it will be like a 8 part. But after midnight until the 6 a.m., we can consider it as 1 part. So automatically it become like a 7 part instead of 8. Since the midnight to the morning, usually people don't use that much, so we can classify it as a 1 part. Okay, so next is we go on to the hidden layer. For this hidden layer, increase it up to our preference. But for this particular case, we use 11 neurons. So for the output layer, it is only one because we want it to give only one output when the input is given. So let's say in the end, so when we start in the time, it will give the power consumption used so they can know. Also, let's say at 3 a.m. there are not many people use the electric. So we can use it as a time to maintain or anything else. So for this, the activation function, we use the sigmoid function as it is a simple relationship between the value function and derivative value at any point. So we go on next. So the proposed performance function is the error histogram. Error, the most error that we get as the instances increase. So in this particular bar graph, we can see that the error is mostly at the 0.03467. This value is quite small and is considered to be a good training function since the error is not too large. So we can see at the y-axis, it represents the instances for of the training. So the highest bar, of course, it represents which range of the error that it gets the most as the instances increase. So with this, we can predict the error in case of we need some proper calculation when we want to calculate the result. Okay, next. Okay. So for the training function, we choose to use the Levenberg-Marquardt algorithm. The Levenberg-Marquardt the training function, Levenberg and Marquardt is in the highest of the function since it is the most efficient and most performance rather than efficient since it still uses a lot of memory for increased computational speed. But usually electric power company already have the capacity, financial capacity to do this, so they can actually implement a machine that are able to learn using a high computational speed and high memory. So I propose this as it is the most highest performance that you can get in a training function. And financially, it should not be a big problem for a big company, which is electrical company, since the customer are most part of the citizen in a country. So I think that's all for our presentation. Thank you very much, and thank you for listening.